P controller. So the P controller stands for proportional control. So proportional control is a type of linear feedback control system. It is control system technology that responds in proportion to the difference between desired value and measured value. So in simple terms, it adjusts the output proportion to the error between the desired and actual values. And the difference between the PID and the PD controller is that the controller is used to achieve accurate and stable control of a system.
So, good day everyone. I'm Cadet Second Class Supply Joseph Dixie, and my topic is about PD or Proportional Derivative Controller. So, PD controller is a type of feedback control system commonly used in engineering and automation. It combines proportional control and derivative control to improve the system's response to changes and disturbances. Uh, so, the difference between PD, PID, and P controller is that proportional controller or P uses only proportional control, while a proportional derivative or PD adds a derivative control to improve transient response, and PID controller incorporates integral control as well as eliminate steady state error and further enhance overall performance. So PID controllers are often preferred due to their ability to handle a wide range of systems and provide robust control under varying conditions.
Good day sir, good day batchmate. I'm Cadet Second Class Balboan Cedric Alberto from PSME 3 Alpha. Today I will explain about PID, or what we call the proportional integral derivative. But first, we must know and understand what is PID. So the PID stands for proportional integral derivative, a type of control loop feedback mechanism widely used in industrial control system. A PID controller continuously calculates an error value as the difference between the desired set point and measured process variable. It adjusts the process control inputs to minimize error using three parameters: the proportional term, or the P, which responds the current error; the integral term, or the I, which accounts for the accumulation of past errors; and the derivative term, or the D, which predict the future errors based on the rate of change. This combination helps maintain the desired desired set point system performance by ensuring stability, responsiveness, and accuracy. So now we will proceed about the difference with the three controllers, which are the PID, or what we call proportional integral derivative; the PD, or what we call the proportional derivative; and the P, or what we call the proportional. So the main difference between the PID, PD, and P controllers lies in component they use to adjust the control output. A P, or the proportional controller, adjusts the output proportionally to the current error. A PD, or the proportional derivative controller, adds a derivative component to the proportional action, providing a corrective action based on the rate of change of the error, which helps predict future error and improve stability and response time. Uh, PID, or proportional integral derivative controller, combines the proportional and derivative component with an integral component, which accounts for the accumulation of the past errors to eliminate steady state error, ensuring long-term accuracy and stability. So I hope you learn something based on what I have said earlier, and which are the what is PID and what is the difference between the three controllers, which are the PID, the PD, and the P. And hope you enjoy. Thank you for watching.
Good day, sir. I'm Cadet 2nd Class Cabanilla Nicojan, and today I will be talking about PID. PID control stands for Proportional Integral Derivative Control. It's a common control algorithm used in industrial automation to regulate processes and systems. Proportional control responds to the current error, meaning the difference between the desired set point and the actual value. Integral control takes into account the past error values over time to eliminate any residual steady-state error. Derivative control predicts future behavior by taking into account the rate of change of the error. The difference between PID to P and PD control is that PID control provides the most comprehensive approach by combining the benefits of proportional, integral, and derivative actions, offering improved performance, stability, and responsiveness compared to P or PD control alone.
What is proportional control? Proportional control is a feedback control system where the output is adjusted the difference between the desired set point and the actual value. It operates proportionally to this error. The stronger the corrective actions. This allows the fine tuning and precise control and system like temperature. It's widely used in engineering automation and even in everyday device like thermostat and cruise control system.
Today, I am tasked to discuss about the PD or the proportional derivative control. So, what is P or the proportional control? This component produces an output signal proportional to the current error signal, which is difference between the desired set point and the actual process variable. And the next one is what is the derivative control? This component produces an output signal proportional to the rate of the change of the error signal. So by combining these two control actions, PD control can provide better performance compared to using either proportional or derivative control alone. The proportional term helps to eliminate steady state errors, while the derivative term helps to improve the dynamic response of the system. So PD control is widely used in various applications, including robotics, industrial automation, process control, and motion control systems. However, it is very important to tune the control parameters or the proportional gain and derivative gain carefully to ensure stable and optimal performance for a given system.
Good and intention everyone. So I'm Kadesek basically from the semi-3 Alpha. So this is my presentation. My topic is all about the PD or the proportional derivative. So first is what is the PD or the proportional derivative? So it's a type of feedback that the control system commonly used to engineering and control theory. So in PD control, the output of the system is adjusted and based on the both current error and the difference between the desired set point and the actual output and the rate of the change of that error. So the difference between the P control and PD control and PID control. So the PID control combines the advantage of all three components to provide the fast response, eliminate the steady state error, and improve system stability. It's more complex to implement, but often it provides the better control to give the provides the better control the performance compared to the just P control and the PD control. So much better yung PID control or the proportional integral derivative control kaysa sa dalawang control, the P control and the PD control na nandun na yung tatlong components na kinakailangan natin kaysa sa dalawang control na yung proportional control and the proportional derivative control. So that's all.
Proportional integral derivative. Proportional integral derivative or PID control is a widely used feedback control mechanism in engineering. It aims to regulate a process by adjusting a control variable based on the error between the desired set point and the actual process variable. Proportional P. Control respond to the current error signal. Integral I. Control integrates the error signal over time to address accumulate errors, while the derivative B, ID, control predict future error based on the current rate of errors.
Good evening, sir. I am Angelo U. Diocarisa from BS Mari Alpha, and I have been assigned to the proportional integral derivative control. So, what is PID control? So, PID control adjusts a system's output to minimize error using three components. The three components which are the proportional, the current error, integral, the past errors, and derivative, which is the rate of error change. It ensures precise and stable control. The difference of PID control to other control, which are the proportional control and proportional derivative, lies in their components and capabilities. Proportional control adjusts output based solely on current error. Proportional derivative control adds consideration of error rate for improved stability and response, while PID control includes past accumulated errors to eliminate steady state error and ensure precise and stable control.
What is proportional integral control? It's a type of feedback control system that is commonly used in automation and engineering. There are two types of control action: set point and process variable, which eliminate steady state error and accumulate errors over time. What is the difference between P control, PD control, and PID control? P control improves stability and maintain steady state error, while PD control responds to changes in error state and reduce oscillation, and PID control improves stability, respond set point action, and disturbance rejection.
Good day, sir. I'm Cadet Second Class Anong Alberto from BSME 3 Alpha. So, what is proportional control? So, proportional control is a type of feedback control system where the controller output is directly proportional to the error signal, which is the difference between the desired set point and the measured process variable. So, an example of proportional control on board is the temperature regulation system in the engine room. The system measures the current temperature and adjusts the cooling water rate proportionally to maintain the desired temperature set point, ensuring efficient in engine operation. So, what is the difference of proportional control to the proportional derivative control and proportional integral derivative? So, proportional control adjusts the output in proportional to the error signal, while the proportional derivative control helps anticipate future error changes. And lastly is the proportional integral derivative control. It eliminates steady error by integrating past errors over time, ensuring durability and accuracy. So that's all.
So, what is proportional control? Proportional control is a control system technology in which the response output is proportional to the difference between a set point value and the current value of a process variable. So, what is the difference between P, PD, and PID controllers? So, P controllers provide proportional control based on present error. Then, PD controllers anticipate future threats by measuring the rate of change of the error, and PID controllers combine all three actions to achieve accurate and stable control with the improved dynamic performance. So, each controller type is selected based on the specific requirements the system being controlled, such as the desired response, time, stability, and acceptable error.
So, what is P control? So, the P control is the proportional control, or P control is the simplest form of control, characterized by the straightforward approach where the control output is directly proportional to the error. So, compared to the proportional derivative control and proportional integral derivative control, or PID control, the primary distinction it is simplest and easy to implementation. So so what proportional control has a simplicity, where P control is the most basic form of control with only one tuning parameter. This simplicity makes it easy to implement and understand. So what PD and PID controls that have and that P control does not. Derivative action, PD and PID. So PD control adds a derivative term to the proportional term. The derivative term is proportional to the rate of change of the error. This helps to predict future errors and improve the stability and response time of the system. So next is the PID control, also includes the derivative term, providing similar benefits. Next is the integral action in PID. So PID control adds on integral term to the proportional and derivative terms. The integral term is proportional to the accumulation of past errors. This helps eliminate steady state errors or offset that P control cannot address. Okay.
Good evening, sir. I'm Cadet Second Class Gonzales 7A's, BSME2 Alpha. So my topic is PD. So P stands for proportional and D stands for derivative. So what is PD? So based on what I have understand, PD controller are typically used in systems where the primary goal is to quick response, respond quickly to changes and reduce overshoot without necessarily eliminating the steady state error. So P, what is proportional? I will differentiate the PD and what PD is difference with the integral, which is the I. So P is proportional. This component provides a control output that is proportional to the current error value. The proportional terms helps reduce the error, but cannot eliminate entirely. Integral, derivative. These components provides a control output that is proportional to the rate of change of the error. It helps predicts the future. So ito ay nagpe-predict ng future errors that acts to dampens the system response, reducing overshoot and improving stability. And anong pagkakaiba ng P and D sa integral? So integral is about the sum of the past error. So these components provides a control output that is proportional to the accumulated sum of the past error. So ito ay nagatulong or helps eliminate the steady state error by adjusting the control output based on the history of the error. That's all. Thank you.
PID, proportional, integral, and derivative, is a control algorithm used to adjust output based on the difference between a desired and actual value. It consists of three components, which is proportional, integral, and derivative. The output value is a sum of these components. It is
commonly used in various industries to control the systems such as robot, engines, and processes.
Good day, sir. I'm Cadet Second Class Gobindadin from BS Marie 3 Alpha. And this the assigned topic to me, PID. What's PID? Proportional Integral Derivative Control. PID control is a common feedback control algorithm used in industrial control system. It adjusts the control output based on the error between the desired set point and the measured process variables. And the difference of PD and PID. P is a control only consider the current error, control the current error signal, while PD control adds the derivative term to anticipate future error change. While PD control the further enhance control performance by incorporating both integral and derivative action alongside proportional control.
What is proportional integral derivative control? Is a widely used control in engineering and automation. It combines three terms: proportional, integral, and derivative. Proportional responds to the current error signal, adjusting the control output in proportional to the magnitude of the errors.
Good evening, sir. So my topic is all about PID or proportional integral derivative. So a control loop feedback mechanism used in engineering. It's commonly used in industrial control system to regulate processes such as temperature, pressure, flow, and speed. It adjusts the control variable based on the difference between and the desired set point in the actual process variable. So PID control is important for several reasons. So number one is accuracy. PID controllers are designed to minimize the error between the desired set point and the actual process variable, leading to precise control of various industrial processes. Next is versatility. PID control can be applied to a wide range of systems across different industries, including manufacturing, chemical processing, automotive, and aerospace and robotics. So the last is stability. PID controls algorithms are inherently stable, meaning they help maintain the system stability by preventing oscillations and instability. Overall, PID control plays a crucial role in ensuring the smooth and reliable operation of industrial processes, leading to increased productivity, quality, and safety.
So, good day to each and everyone. I am Cadet Second Class Leader Smaglik Serens P. So, my topic is all about the PID controller, which stands for Proportional Integral Derivative Controller. So, this controller, it continuously calculates an error value as the difference between a desired set point and a measured process variable. So, it means that it calculates an error value between the desired set point and the measured process variable, and then it applies a control action to minimize the error by adjusting the process variable. So the PID have the and the P and PD controller does not have is the integral term, which is the I. This integral term, it helps to eliminate the steady state error by continuously adjusting the control effort based on accumulated error over time, which means it helps to eliminate the error on a steady state by continuously adjusting the control effort based on the error over time. That's all.
What is proportional derivative? A proportional derivative controller is a type of feedback control system commonly used in engineering and process control. It combines with proportional control and derivative control to achieve a desired system. So, what does proportional derivative control has that proportional controller and proportional integral derivative controller doesn't have? So, the PD controller offers a balanced approach for systems where the derivative actions predictably predictive ability, improve performance without the added complexity and potential instability of integral action in PID controller. It provides enhanced responsiveness and stability over P controllers, and it's simpler and less risky.
So PID controller is a type of feedback control system used in engineering and automation to regulate processes by continuously calculating and adjusting the control input based on the error between a desired set point and the actual output. So PID controller stands for proportional, integral, and derivative, which are the three terms that govern the controller response to the error signal. So the difference of these three, first is controller. It only proportional term, simple but cannot eliminate steady state error. And for the PD control or the proportional derivative controller, it adds derivative term to controller, improves transient response and stability, but still has steady state error. For the PID, it adds both integral and derivative terms, eliminates steady state error, and provides overall control, but it is more complex to tune.
Good day, sir. I am Cadet Second Class Malcampo Densudanti from BSMAR E3 Alpha, and my topic is about the proportional derivative control system. So, what is proportional derivative control system, or PD? It is a feedback mechanism used in control system to achieve desired outcomes by adjusting the control, the input base, or both the current error and the rate of change at the error. So, how do I differentiate the PD on the proportional control and on the proportional integral derivative system? So, first is on the PID. The PD is suited for systems requiring rapid response but not addressing steady state errors, while P is in simple, it provides response but may not handle steady state errors very well. And PID, it provides comprehensive control, balancing stability, accuracy, and responsiveness, widely applicable across various control systems.
Good DPO, sir. My topic is the design is what is proportional control. So proportional control is a technique used in automation this system to regulate a process variable such as temperature, pressure, or flow by adjusting the control output in proportion the deviation of process variable from its desired set point. The control output is calculated based on proportional gain, which determines the rate which is the control output response to change in a process variable. In a proportional control system, the control output is directly proportional to the error between the process variable and set point. As the error increase, the control output also increase linearly. This means that a larger error will result in a large change in the control output, helping to bring the process variable closer to the set point. Proportional control is one of the basic control techniques used in automation, often used in conjunction with other control methods. While it provides a quick response to change in the process variable, it may not be sufficient to eliminate steady state errors completely. that why is common to be combine proportional control with integral and derivative control to achieve better control performance known as PID control.
Pleasant day to each and everyone, and especially to Sir Reyes. I am Cadet Second Class Monarel Car Joshua from BSME 3 Alpha. So my given task is all about proportional control system. So what is the proportional control system? So proportional control system is a proportional control algorithm in which the controller output is the proportional of the error signal, which is the difference between the set point and the process of the variable is in order output is the proportional control in the multiplication product of the error signal and the proportional gain. So the criteria number 2 is what is the proportional control system in PID control system. So the component of the proportional P in the PID control system is to adjust the output of the process based on the current error between the set point and the process variable. The larger the error, the larger the correction applied. So lastly, what is the difference between the P, PD, and PID? So the zero from P is the part may be located close to the origin in the zero. From the PD, the part is placed between a suitable location for desired transient response improvement, while the PID controller imparts both transient and steady-state response improvement to the control system. So that is all. Once again, I am Cadet Second Class Monarel Car Joshua from BSME 3 Alpha.
Hello, I'm Oliveros Gerald Prasby, and I am here to introduce the Proportional Derivative Control System, or PD for short. So, these two are combined to enhance performance for the control system. P stands for proportional. It handles the current error, while derivative handles the rate of change of error. Producing these two, we can anticipate any errors that may happen in the control system. PD or PD control system or proportional derivative control system, the uses are for heating, cooling, robotics, and others. So we can expect a higher performance due to the share of job between the proportional and the derivative. Thank you.
Good morning, everyone. I'm Cadet Second Class Oro Christian Dale, and my topic will be revolved around proportional control. So, what is proportional control? Proportional control is a feedback mechanism used to maintain a desired system output by making adjustments that are directly proportional to the difference between the desired value or set point and the actual value process variables. Well, this corrective action is scaled by a constant factor known as the proportional gain, which determines the responsiveness of the system. The key differences between the proportional, the PD, and the PID controls. Well, the proportional control, its mechanism corrects based on the current error, and the strength simple and immediate. Well, the weaknesses of it is it cannot eliminate steady state error. And that will be all. Thank you.
So this video, we're going to explain the proportional control system. So talking about the proportional control system, it is the fundamental concept in control system engineering that adjusts the output of the system in proportion to the error between the desired value or set point and to the actual value. Proportional control uses a feedback loop to continuously monitor the system's output and compare the desired value. Example, let's say we have a temperature control system in a room. The desired temperature is at 25 degrees Celsius, but the current temperature is 28 degrees Celsius. The error is the difference between the desired and actual temperature, which is 3 degrees Celsius. So the difference between the three control system is the proportional controls a system technology that responds proportional in the difference between the desired value and the measured value. For the proportional derivative control system can respond quickly to changes in the error and provide damping to reduce the overshoot or oscillation. For proportional integral derivative control system used to achieve accurate and stable control of a system.
What is PID control? PID control is a loop feedback mechanism widely used in industrial control system. PID control calculates an error value as the difference between a desired set point and a measured process variable, then applies proportional, integral, and derivative terms to the error to adjust the process. So it means the PID control is like a smart system that helps machines to do exactly what we want by constantly adjusting what they are doing. So the difference between the three, the proportional control adjusts the control variable based on the difference between the set point and the process variable. The proportional derivative control adds a derivative term to improve response time and stability, while the PID control further includes integral terms to eliminate the steady state error and enhance system performance.
So what is proportional control? The proportional control is a type of control system where the output is directly proportional to the errors between the desired set points and outcome process variables. This aims to minimize the difference between the desired output between the desired set point and the output process variable. So the difference between these two proportional control. The proportional control used to adjust the controls based on current errors, while the proportional derivatives added a derivative component to proportional system, which it considered the error state for fastest response, and also while the PID or the proportional integral derivatives use historical errors to eliminate the steady state errors and improving stability.
So, good evening everyone. I am Cadet Second Class Tagibolos in GMAL, and tonight I will be going to discuss the proportional control and differentiate the difference between P, PD, and PID. So what is proportional control? So proportional control is a method used in a control system where the control action is directly proportional to the difference between the desired set point and the actual process variable. So it is also commonly used in engineering and automation to achieve stability and accuracy in controlling systems such as temperature, speed, or position. So, what are the difference between P, PD, and PID? So, in short discussion, P controllers or proportional controllers provide quick response but have a steady state error, while the PD controllers offer faster response and better stability by incorporating derivative action. Lastly, the PID controller, it is a combination of proportional, integral, and derivative action for comprehensive control. It in PID, it also addressing both transient and steady state error.
What is proportional control? Proportional control is a fundamental method used in control system to maintain a desired level of output by continuously adjusting an output signals in proportion to the error, which is the difference between the desired set point and actual output. It is the one of simplest form of control used in various engineering and industrial applications. The effectiveness of proportional controls lie its ability to respond immediately to change in the error. When the error is large, the control action is strong, driving the system output toward the set point more aggressively. Conversely, as the error decreases, the control action diminishes, leading to a more refined adjustment. So that's all. Thank you.
Good day to each and everyone. I am Cadet Second Class TB January K, and my topic is all about the proportional derivative control or DPD. So first, what is proportional derivative control? So this is a feedback control system commonly used in engineering and industrial application to manage the behavior of the dynamic system. So it combines of two types of control actions, proportional control and the derivative control. So the proportional control responds to the current error between a desired set point and measured process variable. So the control actions is directly proportional to this error. So this derivative control is response to the rate of the change of the error. So it predicts the future error based on its current rate of change and adjusts the control actions accordingly. So the main difference of the PD control to other control system is depends on the components they use. So and their effects on their system performance. So the P control only current error focuses. The PD control current error plus rate of error change are focuses. While the PID control is current error plus accumulated past error plus the rate of error change. And that's all. Thank you.
So, good day sir. I'm Cadet Second Class Tomal Jairus from PSMT Alpha. And my topic is about proportional control. So, what is proportional control? It's a fundamental concept in control system used in various industries to maintain desired output by minimizing error between set point and process variable. So, how can I differentiate proportional control, proportional derivative control, and proportional integral derivative control? So, proportional control offers simplicity and basic error reduction but leaves a steady state error. And for proportional derivative control, enhances stability and response by adding a predictive element but still cannot eliminate steady state error. And the last is proportional integral derivative control, with its comprehensive approach, addresses both transient and steady state performance, making it the most effective in widely used control strategy and practice.
My name is Ian J.C. Zaragoza. So today I'm gonna tackle what is PID. Proportional integral derivative, PID for short. A controller is a control loop mechanism widely used in an industrial control system. It uses feedback to maintain the desired output as a simple system by adjusting control inputs. A PID controller calculates an error value as the difference between a desired set point and a measured process variable and applies correction based on three parameters.
I'm Gamos RLP, BSME3 Alpha. My topic is all about PD. PD stands for Proportional Derivative Controller. PD controller is a type of feedback control system commonly used in industrial control systems and robotics. It is simple and easy to implement and effective in systems where a quick response is required. The difference between P controller, PID controller, and PD controller is that P controller is simple, quick response, but may leave a steady state error PD controller reduces overshoot and improves stability but does not eliminate steady state error. PID controller, comprehensive control with no steady state error, improves stability and good response speed but more complex to tune.